So let's say you have a problem where you're given a function for a wave, and in this case we have the following. We have y is equal to 6.0 times 10 to the negative 3 times cosine of 20x plus 4t plus pi over 3. Each one of the elements inside of this wave represents a different value, a different quantity. In the general form, we have y equals a times cosine of k times x plus omega times t plus delta, where each one of these quantities represents something different. A is going to be the amplitude, and that's going to be 6 times 10 to the negative 3. K will be the wave number, that's going to be 20. Omega will be the angular frequency, that's going to be 4, and then delta is going to be the phase of your actual wave. So what if we're asked to find the maximum of this function, or where the maximum of this function occurs for a given value of x? Let's say maybe if x equals 0, find the time that this function, that this wave, is at a maximum. So in order to do this, first we have to plug in the value that we're given. We're given x is equal to 0, so we can plug that in. So now we can rewrite our wave as y is equal to 6.0 times 10 to the negative 3 times cosine. And when we plug in our 0 for x, that 20 times 0 goes away, and we get rid of the 20, and we end up with cosine of 4t plus pi over 3. And now the question becomes, how do we actually find the maximum of this? And if we remember, finding the maximum of a function means that we take the derivative and we set it equal to 0. So this should be stuff that you remember from your prerequisite courses and from earlier in the semester when we found some maxima. So I would need to take the derivative of y, and I need to take that derivative with respect to the variable t with respect to the time. And I can do that pretty easily. The derivative of cosine is going to be negative sine. So I'm going to get negative 6.0 times 10 to the negative 3 times 4 times sine of 4t plus pi over 3. I want to take this derivative and I want to set it equal to 0. That's how I find a maximum. I take the derivative first, and then I set it equal to 0. So I need to find out how I can make this function equal 0. The only way I'm going to do that is if this sine term is going to be equal to 0. So let's make some room. Let's see if we can find sine of 4t plus pi over 3 has to be equal to 0. And we need to know when that actually happens. So this requires us to know, when does the sine of an angle equal 0? So what angles can I plug into here? What angles will give me 0? It turns out that I will get sine of an angle is equal to 0 whenever this angle is equal to some multiple of pi, n times pi, where n can be equal to 0 or 1 or 2 or 3, so on and so forth. You can look this up in your integral or in your constant sheet, in your tables. You can know this from the unit circle, any of these different approaches to figuring out when sine is equal to 0. So I need 4t plus pi over 3 to be equal to n times pi. Now, to finally find what times I need, I can solve all of this for t. So first, I want to subtract the pi over 3 to the other side. So I get n pi minus pi over 3. And then I want to divide both sides by 4. to get the t by itself, and I get n times pi over 4 minus pi over 3 times 4, which is going to be 12. So any of these times will give us the value that we're looking for. Will give us the times at which point we have a maximum for x is equal to 0. So this gives us our general equation, and if we actually want to get some numbers out of this, we can get some numbers. We can plug in n is equal to 0. And when n is equal to 0, that's going to give us our first time when we have the maximum. So we can do t is equal to 0 times pi divided by 4 minus pi over 12. And when you plug this into your calculator, you'll find that you get about negative 0.26. That's going to be seconds. Then to find additional answers, we can find additional answers by plugging in more different values of n. We can plug in and find a time for n is equal to 1. So this is going to be the next time that we're going to get a maximum value from this wave. And we're going to plug in t is equal to 1 times pi, all divided by 4, minus pi over 12. And when you plug in all your numbers, just plug that into your calculator, you'll find that you get 0.52 seconds. And you can keep doing this, so on and so forth, for every value of n that you want to plug in. Maybe n equals 2, n equals 3, and so on and so forth.